This is our 2018 STEM Quantum Computing Capstone by Nolan Emery, John Iveson, Kevin Ewan, mentored by Rito Perella.
Our project objective was a lot harder to define than most projects. Ultimately, we wanted to experiment with programming quantum computers. However, before we could start programming, we had to learn about quantum mechanics and how quantum computers work.
As we begin to reach the maximum capacity for silicon transistors, more and more processing power is needed. Classical computers are not able to solve problems where the numbers of possible outcomes grow exponentially. Many of these problems could take classical computers billions of years to solve because of all the possible outcomes from the large sets of data.
This is where quantum computers become useful, as they could theoretically be able to solve these problems in a matter of minutes. Such problems include molecular modeling, astrophysics modeling, cryptography, as well as other complex optimization problems. The programs available to quantum computers right now are relatively simple. However, these are the building blocks for more profound applications that quantum computers will be able to solve in the years to come.
To ensure we stayed on task, our mentor put together a spreadsheet of tasks that we had to complete.
For communication, we used a variety of different methods to stay in touch with our mentor and with each other. Between ourselves, we used a Facebook group chat, but to communicate with Rita, we sent emails. We used a shared Google Drive folder to share all of our documents online for instant access anywhere. We also met with our mentor almost every other week so we could discuss the progress we made. For each task and project, we had a team lead responsible for assuring that the tasks and projects got done.
Because of this project, we now have a high-level understanding of the key basics of quantum mechanics and quantum computing, such as the Bloch sphere and quantum gates. To understand quantum gates, we also had to research the basics of matrices. One of the toughest things for our groups was setting goals. Since our project was a research project, we had trouble setting hard goals, which led to a lack of motivation within our project. As our project is more theoretical/research-based, it was challenging to find material that was readily available, describing the complexity of quantum computing and quantum mechanics at a beginner or intermediate level of comprehension.
A big takeaway for me from this project was learning to prioritize, as there were a lot of times when we could have gone off and researched very specific topics that would have taken the project in different, mostly unrelated directions. However, to stay on task, we had to decide what was the most important for our project and then what we're going to research.
My main takeaway from this Capstone project was the amount of research and knowledge that I was able to gather in regards to quantum mechanics. And unfortunately, before we could have gotten into quantum computing, we had to get into quantum mechanics. And that's a bottomless rabbit hole that consumed a lot of unnecessary time. And due to its vast field that's mainly based on theoretical models, it was a challenge to determine what was and wasn't important to the learning of the project.